Welcome to Why Walking Matters, the Science Explained. I'm Tatiana, and in this episode, I'll share an inspiring read with science backed insights about the benefits of walking for healthy aging. So lace up, take a breath, and let's walk together. This article is from pubmed.ncbi.nlm.nih.gov. And remember, links to all articles are always in the podcast description. NIH, National Library of Medicine, National Center for Biotechnology Information, an official website of the United States government. Review, Geroscience, December 2023. The multifaceted benefits of walking for healthy aging, from blue zones to molecular mechanisms, by Zoltan Ungvari, Vince Vasikas Pongor, Anna Chisar, and Sator Knutsor. Abstract: Physical activity, including walking, has numerous health benefits in older adults, supported by a plethora of observational and interventional studies. Walking decreases the risk or severity of various health outcomes, such as cardiovascular and cerebrovascular diseases, type 2 diabetes mellitus, cognitive impairment, and dementia, while also improving mental well being, sleep, and longevity. Dose response relationships for walking duration and intensity are established for adverse cardiovascular outcomes. Walking's favorable effects on cardiovascular risk factors are attributed to its impact on circulatory, cardiopulmonary, and immune function. Meeting current physical activity guidelines by walking briskly for 30 minutes per day for 5 days can reduce the risk of several age associated diseases. Additionally, low intensity physical exercise, including walking, exerts anti aging effects and helps prevent age related diseases, making it a powerful tool for promoting healthy aging. This is exemplified by the lifestyles of individuals in blue zones, regions of the world with the highest concentration of centenarians. Walking and other low intensity physical activities contribute significantly to the longevity of individuals in these regions, with walking being an integral part of their daily lives. Thus, incorporating walking into daily routines and encouraging walking based physical activity interventions can be an effective strategy for promoting healthy aging and improving health outcomes in all populations. The goal of this review is to provide an overview of the vast and consistent evidence supporting the health benefits of physical activity, with a specific focus on walking, and to discuss the impact of walking on various health outcomes, including the prevention of age related diseases. Furthermore, this review will delve into the evidence on the impact of walking and low intensity physical activity on specific molecular and cellular mechanisms of aging, providing insights into the underlying biological mechanisms through which walking exerts its beneficial anti aging effects. Introduction. The Western world is experiencing a significant demographic shift as the population ages. According to the United Nations, the number of people aged 60 years or older is expected to more than double by 2050, reaching 2.1 billion. With this increase in the aging population comes a greater focus on healthy aging, which involves maintaining physical and mental health as people age. One area of research that has gained attention in recent years is the study of determinants of healthy aging in the blue zones, regions of the world where people live longer, healthier lives than anywhere else. Researchers have identified 5 blue zones around the world, including Okinawa in Japan, Sardinia in Italy, Nicoya in Costa Rica, Icaria in Greece, and the Seventh day Adventist community in Loma Linda, California. These regions have the highest concentration of centenarians, people who have lived beyond 100 years, and the lifestyles of the people living in these regions have been studied to determine the factors contributing to their longevity and healthy aging. This research has identified several factors that contribute to this phenomenon, including diet, social connectedness, and physical activity. One of the key lifestyle characteristics of blue zone populations is their high levels of physical activity, which includes regular walking in addition to other low intensity physical activities. These populations engage in physical activity as part of their daily routine, such as walking to work or for daily errands, gardening, and performing other manual labor activities. Numerous studies have evaluated the evidence linking walking and physical activity, in addition to other lifestyle factors in blue zones, to healthy aging and longevity. In the Nicoya Peninsula of Costa Rica, physical activity is an integral part of daily life. The region's terrain is hilly, and the residents often walk long distances to work or to visit friends and family. This continuous movement, coupled with a healthy diet rich in whole grains, fruits, and vegetables, contributes to the long and healthy lives of the Nicoyans. Similarly, on the Greek island of Icaria, where the terrain is rugged, residents engage in extensive walking and often participate in physical labor activities such as farming and goat herding. In Sardinia, walking and other physical activities also play a crucial role in healthy aging. To promote healthy aging, health promotion programs should focus on the determinants of healthy aging identified in the blue zones. Regular physical activity, including walking, is a fundamental aspect of a healthy lifestyle and is associated with numerous health benefits, particularly in the context of healthy aging and longevity in the blue zones. Therefore, health promotion programs designed to promote healthy aging should prominently include recommendations for walking in addition to other forms of regular physical activity as a way to improve overall health and well being. Though the terms physical activity and exercise are commonly used interchangeably, they are not necessarily the same. Physical activity is defined as any bodily movement produced by skeletal muscles that requires energy expenditure and includes exercise as well as usual occupational and or domestic activity. In contrast, exercise is intentional physical activity and can include aerobic training, high intensity interval training, or resistance training. The evidence supporting the health benefits of physical activity and exercise training is extensive and consistent. Regular physical activity is linked to a reduced risk or severity of adverse vascular outcomes, such as cardiovascular disease and type 2 diabetes, as well as non vascular outcomes including various cancers, osteoarthritis, and infectious diseases. Importantly, the beneficial health effects of physical activity are irrespective of age, sex, ethnicity, or the presence of comorbidities. Furthermore, regular physical activity and exercise training are also well documented to increase levels of cardiorespiratory fitness, which is one of the strongest predictors of adverse cardiovascular outcomes. Cardiorespiratory fitness is often characterized as maximal oxygen uptake (VO2 max) or peak VO2 (VO2 peak). Promoting physical activity has been an important strategy to specifically reduce the prevalence and incidence of common cardiometabolic conditions all over the world. Components of physical activity include frequency, duration, and intensity, which together comprise the volume. To derive the maximal benefits of physical activity, an appropriate intensity, frequency, and duration are required. Physical activity can also be classified based on the level of intensity: light, moderate, and vigorous. Despite current physical activity guideline recommendations, which state that adults should engage in at least 150 to 300 minutes of moderate intensity physical activity or 75 to 150 minutes of vigorous intensity physical activity per week, or an equivalent combination of both types of physical activity per week, there is a research gap regarding the dose response association between volume and intensity of physical activity and health outcomes. Walking is the most commonly reported physical activity and is often classified as light or brisk. Light walking is classified as low intensity physical activity, and brisk walking as moderate intensity physical activity. While the cardiovascular benefits of walking are widely acknowledged, there is uncertainty regarding the ideal dose required to reap cardioprotective benefits, as well as the impact of walking on non vascular outcomes. Conflicting data also suggests that the intensity of physical activity may be associated with greater benefits than the quantity. The objective of this review is to provide a comprehensive summary of the extensive literature on the health benefits of walking in older adults, including the cardiovascular benefits and postulated biologic mechanisms underlying the associations between walking and health outcomes. Additionally, this review aims to examine the implications for clinical practice and population health and to provide recommendations for future research directions. Specifically, this review will explore the role of walking in promoting healthy aging and improving health outcomes in older adults, with a focus on the specific recommendations that should be included in health promotion programs targeting physical activity, particularly walking. Furthermore, the review will investigate the anti aging effects of walking, offering valuable insights into the potential contribution of walking to healthy aging. Health benefits of walking. Methods. We conducted a thorough search for observational studies, including prospective cohort, nested case control, case cohort, or retrospective cohort studies, randomized controlled trials (RCTs), and non-RCTs from Medline and Embase up to May 2023. Our search focused on the cardiovascular benefits of walking, with a particular emphasis on robust, systematic reviews and meta analyses of these study designs when available, according to the hierarchy of evidence. Our search terms included a range of keywords related to walking and cardiovascular health, such as cardiovascular disease, coronary heart disease, sudden cardiac death, heart failure, hypertension, and blood pressure, as well as keywords related to other health outcomes, including dementia, depression, anxiety, pulmonary disease, sleep, fracture, mortality, lipids, inflammation, oxidative stress, arterial stiffness, arterial compliance, and intima media thickness. We restricted our review to studies conducted in human populations, reported in English, and in adults. While steps per day is a commonly used metric for quantifying physical activity, it captures all types of activities involving a movement made by lifting your foot and putting it down in a different place, including walking and running. As such, this review did not specifically focus on studies that used the measure of steps per day. However, we included studies that captured walking activities using accelerometer-derived daily step count, such as 40 steps per minute or faster, defined as intentional walking or purposeful movement, or 100 steps per minute, defined as moderate walking pace or brisk walk. We excluded studies that examined walking in combination with other physical activity types, such as cycling. Additionally, cross-sectional studies were not included as they do not address temporality. An important goal of this review was to provide a comprehensive overview of the existing evidence on the cardiovascular and other health benefits of walking and to explore the biologic mechanisms underlying these associations in promoting healthy aging. Cardiovascular outcomes, cardiovascular risk factors. Several observational cohort and interventional studies have explored the impact of walking on cardiovascular risk factors. However, the results of these individual studies have been conflicting, leading to several systematic reviews and meta analyses on the topic. One meta-analysis conducted by Kelly and colleagues evaluated the effects of walking on resting systolic blood pressure (SBP) and diastolic blood pressure (DBP) by pooling data from 16 RCTs and non-RCTs. The study showed that walking exercise programs led to mean reductions in SBP and DBP of 3 and 2 millimeters of mercury, respectively. Another meta-analysis by Murphy and colleagues pooled data from 24 RCTs to quantify the effect of walking interventions on selected risk factors, including aerobic fitness, blood pressure, and measures of body composition. The study showed that walking interventions increased aerobic fitness and decreased body weight, body mass index (BMI), percent body fat, and resting DBP in sedentary adults. Other meta-analyses have shown that walking significantly decreased glycated hemoglobin A1C, BMI, and DBP, and increased VO2 max, while having no effect on high density lipoprotein cholesterol, HDLC, or low density lipoprotein cholesterol, LDLC levels. Overall, these findings suggest that walking is associated with significant improvements in cardiovascular risk factors and also has the potential to be used as a therapeutic tool for individuals with T2D, type 2 diabetes. Regular exercise, including walking, has a profound impact on endothelial function, which plays a critical role in cardiovascular health. Endothelial cells line the inner surface of blood vessels and are responsible for regulating vascular tone and thereby blood pressure, maintaining vascular integrity, regulating hemostasis, and platelet aggregation. The preservation of endothelial health is paramount in preventing the development of atherosclerosis and pathological vascular remodeling in large vessels. Equally important is the maintenance of microvascular endothelial health, as it plays a crucial role in preserving capillary architecture, regulating the tone of resistance arteries to ensure adequate nutrient and oxygen delivery to tissues, and maintaining barrier function, such as the integrity of the blood brain barrier. Additionally, microvascular endothelial cells are involved in modulating the exchange of molecules, regulation of immune cell function, including leukocyte extravasation, and supporting the maintenance of stem cell niches. Aging is commonly associated with generalized endothelial dysfunction, which negatively impacts the proper functioning of both the large vessels and the microcirculation. This age related endothelial dysfunction compromises the overall health and disrupts the homeostasis of various tissues and organ systems. Age related endothelial dysfunction contributes to the development of macrovascular atherosclerotic diseases, including stroke, coronary artery disease, peripheral artery disease, and microvascular diseases, including microvascular pathologies affecting the heart, brain, kidneys, skeletal muscle. Exercise promotes endothelial health in aging by promoting an anti inflammatory, anti atherogenic gene expression profile, stimulating the production and release of vasodilator nitric oxide, NO, and promoting angiogenesis. Exercise induced shear stress plays a crucial role in regulating various aspects of endothelial function and phenotype. Increased blood flow and shear stress during exercise trigger the release of endothelial derived NO, leading to vasodilation, lowering blood pressure, and improving tissue perfusion. This vasodilatory effect not only enhances oxygen and nutrient delivery, but also facilitates the removal of waste products. Shear stress can modulate the expression of proatherogenic and antiatherogenic genes and activates various intracellular signaling pathways, including those involved in antioxidant defense and vascular remodeling. These mechanisms collectively contribute to the maintenance of a youthful endothelial phenotype and the prevention of endothelial dysfunction and atherosclerotic plaque formation. By promoting favorable shear stress and regulating gene expression, exercise serves as a powerful modulator of endothelial function. By enhancing endothelial function, exercise promotes optimal cardiovascular function and vascular health in older adults and reduces the risk of endothelial dysfunction associated conditions such as hypertension, atherosclerosis, and CVD. Hypertension. The blood pressure lowering effect of walking has been widely investigated in observational cohort studies and RCTs, as discussed in the previous section on cardiovascular risk factors. Prospective cohort studies have also reported associations between walking and the risk of hypertension. For instance, a study of 6,017 Japanese men aged 35 to 60 years without a history of hypertension or diabetes at baseline found that walking for longer durations was associated with a reduced risk of hypertension. Specifically, compared to a walk of 10 minutes or less, an 11 to 20-minute walk and a walk of 21 minutes or more were associated with a 12% and 29% lower risk of hypertension, respectively. Similarly, a study of 15,357 university graduates initially free of chronic disease or hypertension found that a normal, brisk, or very brisk walking pace was each associated with a reduced risk of hypertension compared to a slow walking pace after adjusting for established risk factors. Moreover, a recent prospective analysis of 83,435 postmenopausal women aged 50 to 79 years without known hypertension, heart failure, coronary heart disease, CHD, or stroke found that walking at guideline recommended volume greater than 7.5 MET hours per week and at faster speeds greater than or equal to 2 miles per hour was associated with a lower risk of hypertension, cardiovascular, and cerebrovascular diseases. Several prospective epidemiological studies have been conducted to investigate the associations between walking and CVD outcomes. In 2008, Hamer and Chida conducted the first systematic review and meta-analysis of these studies, which included 18 prospective studies comprising 459,833 participants free from CVD at baseline, with 19,249 CVD cases at follow-up. The authors found that comparing the highest versus the lowest walking category was associated with a 31% reduced risk of CVD. Another meta-analysis by Zeng and colleagues in 2009 found that an increase of approximately 30 minutes of normal walking a day for 5 days a week was associated with a 19% reduction in CHD risk, with no evidence of a difference between men and women. Other studies have reported dose response reductions in CVD risk with higher walking duration, distance, energy expenditure, and pace. Additionally, walking at a brisk, fast pace was associated with a 24% and 21% reduced risk of CVD mortality, respectively, compared with walking at a slow pace. Other studies reached similar conclusions. In analysis of the UK Biobank, comprising 318,185 participants, Celis Morales and colleagues investigated the associations between usual walking pace and range of health outcomes. In fully adjusted models, compared to slow-paced walkers, men and women with a brisk walking pace had a 38% and 53% reduced risk of CVD mortality, respectively. In another analysis of the UK Biobank cohort, slow walking pace compared with average walking pace was associated with a higher risk of stroke. In the overall study population of 363,137 participants. In a subgroup analysis, the association was only existent among participants aged greater than or equal to 65 years. In pooled analysis of 8 prospective cohort studies that examined the association between walking pace and stroke risk, individuals in the fastest walking pace category had a 44% lower risk of stroke compared to individuals in the slowest walking pace category. In dose response analysis, every 1 kilometer per hour increment in baseline walking pace was associated with a 13% decreased risk of stroke. In addition to walking pace intensity, a number of individual studies have reported incremental dose response reductions in the risk of adverse cardiovascular outcomes in relation to increasing walking duration or distance and higher energy expenditure from walking. In a recent analysis of the UK Biobank, in which data on accelerometer measured daily step count was available for 78,500 individuals, more daily steps, including purposeful or intentional walking steps, were associated with lower CVD incidence and mortality. Thank you for listening to Why Walking Matters, The Science Explained. This has been part 1 of a comprehensive summary of the extensive literature on the health benefits of walking in older adults. Tune in next week for part 2. And remember, if you're enjoying these podcast episodes, please share with a friend and let me know by sending me a text or an email. Until next time, listeners, keep walking with purpose.